Okay. That sounds like it's working. All right, well, thank you so much for having me here. It's a pleasure to visit Iowa City for the first time in my life. So it's interesting that I'm supposed to be here to talk about things that are of great public import, because a decade ago, I think if you had asked philosophers if the problem of free will was interesting or of any import, most of them would say, like, oh, that old problem, it's just dead. Nobody's thinking about that anymore. Maybe now a little bit more than a decade ago, but I think that things have changed considerably. So today I'm just going to go through some recent neuroscientific results about, or purportedly about free will, and talk about what they tell us, if they tell us anything. But we're going to start off with a little bit of philosophy. So the relationship between free will and responsibility. So most people care about free will because it has implications for responsibility. So there are a number of intuitive things that most people believe. They seem to think that, or most people seem to think that these are relatively obvious. That for you to have moral responsibility for doing some action A requires that you do that action freely. That's one. And that what it is to do something freely is to have the capacity, or to be able to have not done that thing, right? To be able to refrain from doing that thing. And then most people think that there's a close relationship between freedom and consciousness, that if you do something unconsciously, it's not something that you freely do. And within so just keep those things in mind, but in the discussions about free will, there have been two major things that have been raised, partially based on these kind of intuitive platitudes. Two major threats that have been proposed to free will. One is from determinism, and one is from the threats to conscious will, so the denial that we actually do things, or will things consciously. So we'll talk about both of them in the course of this. So let's start with determinism. Determinism is actually a technical term, and so this is one way of cashing it out. Determinism means that that if you had a complete specification of the state of the world at any particular time, and all the laws, knew all the laws of nature, then you would be able to fix the state of the world at any other time. So basically, the complete specification of the world and all the laws of nature would allow you to sort of evolve the world forward and backward in time. Another way of saying it is, given those things, there's only one way the world could be. So keep that in mind as well. And this is a little primer on how the notion of freedom and determinism interact. So if you think about determinism, there's two possibilities. One is that determinism is true, and the other is that determinism is false, in which case indeterminism is the case. Okay, so that's what you have on this axis here. And then you could have two possibilities about freedom, and those are interacting with this question of whether determinism is true. So you could believe that we have free will, even if the universe is deterministic. And that set of views, there are a number of different varieties, but you can call that family of views compatibilist views, also sometimes called soft determinism. So the idea is that freedom is compatible with determinism. You might think, though, that if the universe is deterministic, then everything we do is determined, and so there's no way that we could be free. And so then you would be a hard determinist, okay? So you'd live down in this corner. Or you might think, well, determinism is not compatible with freedom, but the truth, or determinism itself is false, right? The universe is not deterministic. So then you would live in that corner. So the idea that we do have free will and we have it in virtue of the falsity of determinism is libertarianism. And you can see that both of these views, hard determinism and libertarianism, are called incompatibilist views, just indicating that freedom is not compatible with determinism. And then what varies is whether or not determinism is true. And then there's some people that live in that other quadrant. We won't talk about them right now. But those are the general guys. Okay. So we're now in a position to escape from this ignorance because of different kinds of sciences. So the brain sciences, for instance, are giving us some insight into the causal bases of behavior. We have new technologies. Yeah, new technologies that allow us to see things that we couldn't see before. And we have interdisciplinary approaches that allow us to synthesize insights from the neurosciences and other areas, such as economics and with respect to decision making. And so, in fact, this problem of free will is, again, a live question. And some people, people have very different reactions to it. So some, for instance, this neuroscientist, Jeff Schall, thinks that neuroscience actually shows that we lack freedom. He says, by monitoring the signals produced by appropriate neurons, an experimenter can predict and even influence what a monkey will choose. Ethics, not theory, would preclude an investigator from obtaining the same relationship with a human agent. Can this ability to predict and influence be reconciled with a belief in freedom and responsibility? And he thinks that it can't be. Saul Smolansky thinks that this is actually the case, that we don't have freedom, but that it would be a catastrophe if people came to believe that freedom is a necessary illusion and the truth should be reserved for the intelligentsia that have the ability to handle that bad news. So he warns that our fundamental values, practices, and attitudes, such as abhorrence of the punishment of the innocent, the inherent value we put on equality of opportunity, belief in our potential for blameworthiness, are all very likely to be harmed, and that people might succumb to an unprincipled nihilism. Okay, so that if we were to come to realize that we lack free will, it would be terrible for society. While other people like Josh Green and Jonathan Cohen think that it would actually be great for our society to realize that free will doesn't exist. He said, we'll stop thinking people are responsible and that they deserve punishment, but that's actually good. It will be good for society to just think in a forward-thinking way, and he'll say that, or they say that the law will continue to punish misdeeds as it must for practical reasons, but the idea of distinguishing the truly deeply guilty from those who are merely victims of neuronal circumstances will seem pointless. So they actually think that we should just be utilitarian and do things that would make people behave the best that they can behave, but don't actually think of them as responsible beings. So there's this view that determinism is a threat to free will, and that if our brains are shown to be deterministic, then there would be significant societal consequences, whether good or bad. But I want to address the question of whether determinism really is a threat to free will by looking at whether or not the sciences, or in this case neuroscience in particular, is in a position to show that it is true or false. And I will very briefly argue that there are two reasons to think that it can't. One is what I call the problem of fundamental neural indeterminacy. And that is what we see when we look at the brain is a bunch of events, but events that may appear to be predictable, and thus we might think that their predictability is in virtue of determinism, or they may appear to be unpredictable. But we really can't distinguish true determinism and indeterminism from merely apparent determinism and indeterminism. So this is really an epistemic issue, and predictability itself, which is what we have access to when we do experiments, is not a reliable guide to whether or not determinism is true. It's just some operational measure that we have, but it actually cross-cuts the determinism-indeterminism question. And so to just see this illustrated, think about chaos. So chaos is unpredictable. That is, you cannot predict the future or past states of a chaotic system if you don't know the governing laws, but that system can be entirely deterministic. So you might look at such a system and think, oh, that's an indeterministic system, but in fact it's purely deterministic. And then there's quantum mechanics, which at the macro level looks completely deterministic, but our best theory suggests that in fact at the quantum level it is indeterministic. So You can't tell just from looking at scientific results whether determinism or indeterminism is true. The second problem that I think rules out neuroscience as a means to answer the question of determinism is what I call the problem of exhaustive neural determination. And I'm just illustrating how incredibly complex the brain is. So here you can just see this is a wiring diagram between areas of the primate visual cortex. And they're massively interconnected, but these are just schematics of what areas connect to what other areas, and virtually 20 years ago. And so between all of these areas are in fact millions and upon millions of connections, and you can't actually isolate individual systems because the whole system is massively interconnected. So if you were to look at a system, at one part of the system and say, oh, there's activity here, is this predictable or unpredictable activity? Well, the only way you could say that is if you knew what the activity of the whole rest of the system is and how that system was wired up. And so you actually have to have global knowledge of the system, which we cannot get from neuroscience. And just to give you a sense of what this looks like at the neuronal level, this is a wiring diagram of, I think, the only organism that we have a wiring diagram for. It's a very simple worm with 302 neurons. And this is how interconnected those are. And if you think that our brains have something like 10 to the 12th neurons, and each neuron has something like 1,000 connections to other neurons, you can imagine what kind of combinatorial problem it is to understand how everything is influenced by everything else. So again, I don't think neuroscience is ever going to give us this ability to say whether some unexpected event that we see in the brain is actually due to just causal activity from other events in other parts of the brain, or something that is truly an indeterministic event. So that might lead you to think that there's no way that we can really answer this question. But I think that there are ways to address the question of free will in a slightly different way, not from the question of whether determinism is true, but just by looking at some of the things that we think are characteristic of free will. So I've argued that you can operationalize free will by looking at different kinds of functions that the brain does, or that we do. And so I've outlined a few of them. One is initiation of motion. Another is intention. Another is decision-making, executive function, and phenomenology. And today I'm only going to talk about the first few. So initiation, intention, and decision-making. And some of you might be familiar with this study of Benjamin Libet that I think has taken on a life of its own. And what he did was he hooked people up to an EEG machine. So he got recordings from their scalps, and he asked them to spontaneously move their finger whenever they felt the urge to, which was essentially a way of saying, move in an uncued, spontaneous way. Move purely volitionally. And they did that while they were hooked up to the EEG. They also had an EMG that measured when they actually moved. And at the same time, they were looking at a clock that had a dot that went around, and they were supposed to report to the experimenter when you first decided to move or felt the urge to move, where was the spot going around, so that the experimenter could then time the moment in which the willing occurred. So here's an illustration of what it might look like. This is a EEG cap that you have on somebody's head, and they're moving their finger. And you collect a bunch of different trials of them moving, and you time lock them all to this 0 point, the point at which the muscle movement occurs, so the EMG. And so what you see in all these traces is a noisy signal from the scalp that's reflective of neural activity, that if you sum together, you get this thing that we call the average readiness potential, or the RP, which Libet called preparatory activity for volitional movement. So this is what the form of the RP is, and here's the experiment that I described to you. And that question that he asked is, when are you conscious of willing with respect to when your brain activity occurs? Okay, so when do we will to make the action with respect to this RP signal that we can measure from the brain? And what he found was that people's, so here is where the person actually moves their finger. Here was the point at which motor activity in the brain, so it takes time for your brain to signal to your finger to move. And when people judged that they willed to move, it was a little bit before that, so about 200 milliseconds before they actually moved. But if you look at the time course of the RP, and you can just look at this one here, that RP starts about 500 milliseconds before people actually move. So Libet reasoned, well, it looks like your brain has decided to move before you ever decide to move, right? W is the time of willing, so that's when you decide to move. But if you look at where the RP starts, it's way back here. And so he argued that will, conscious will, is illusory. We don't actually will our actions. Our brain just does things for us. And his interpretation was that we don't have free will. Well, the best that we could do is we could have free won't. So there might be a point in between when we consciously will and when we send our signals, when the brain sends its signals to the rest of our body to do something, to veto the action that our brain has caused kind of on its own. And so he asked whether we have free won't, or suggested that, you know, if there is hope for free will, it's just in the capacity for free won't. So I'm going to give you a number of criticisms of this paradigm. There are many of them. So one is that the way that this experiment is set up, I don't think that it's well designed to probe whether or not people decide to move or not, but it's actually what you're doing is you're an experimenter giving people instructions. They may be vague instructions, but you're saying, you know, decide when you want to move your finger. And so what they're doing is following an instruction. So it's not paradigmatic of free action. It also seems that these kind of simple motor movements aren't the same kind of movements you'd be actually interested in if you were worried about the problem of free will and responsibility, because we're not worried about the responsibility of moving our fingers. We're worried about things like you know, picking up guns and killing people, or doing other kinds of more complex activities. And it turns out that you can't build up complex activities merely by adding together simple activities. So it turns out that your brain's logic for moving your hand like this is not just adding up the neural activity of moving each individual finger, but in fact, it takes a lot more neural activity to move one finger than it does to move your whole hand. And so you can't actually infer about complicated actions just by looking at these simple ones. And even so, suppose it were true that these very short time scale things are in some sense out of our control. There's clear evidence that we can affect what we do on much longer time scales. So there are studies like Goldwitzer's studies on implementation intentions that suggest that people who make commitments to do certain things in advance actually follow through with those things much more often than people who don't make those commitments. And so there's lots of evidence that we can do things in advance. We can change our future behavior by doing certain things in the present. So I think those things call into question just whether this simple finger movement paradigm is a good one. There are other experiments that suggest that the RPs aren't really linked specifically to motor actions or motor intentions, and that they can occur in the absence of conscious intention, so they're also not linked specifically to voluntary movements. And so they're not actually giving you the specific kind of signature that you're interested in when you're talking about questions of free will. Another kind of study shows that we can actually stop ourselves from doing actions much later than you would think if it were this very simple kind of series of events that caused you to move after the RP. So we can stop actions long after the RP onset, long after motor preparation, even after there's signal from the brain to move your finger, you can still stop that action from occurring. So it's not just a series of mandatory actions that stem from some activity occurring in your brain. And these are other papers that show that RPs occur with all kinds of decision-making that are cognitive and not motor, and that even people under hypnosis who are not voluntarily moving at all are, in fact, creating things that look like RPs when you measure from their scalp. My favorite reason to think that this is not a very good paradigm for studying free will is that I don't even think that this is an accurate measure of the time of willing at all. And to see why, think about what exactly you have to do in order to do the Libet task, to report on the time at which you will something. You have to perform at least two different tasks. One is the task of spontaneously moving your finger, and the other is the task of reporting at what time you were aware of the intention to move. And that report requires that you, number one, focus inward and recognize when you have an intention to move, and then shift your attention to the outer world and link that time with the clock. But we know from lots of science that shifts in attention are actually temporally extended, so it takes time to make that shift. And so what you're asking for when you ask for W is really, when you ask for the report, is a metastate, right? A state of awareness about a state of willing, not the state of willing itself. And so if we look back at this diagram, this is what Libet said was where willing was. But if you take my argument, then it seems like willing is going to happen sometime before. It could happen any time before this time, because attention takes time, but we don't know how much. And the point here is really when you're conscious of intention, but not the point at which you willed to do something. So think about, for instance, coming to a stoplight and you see the light is red and you slam on the brakes. And you do it voluntarily, you do it consciously, and I would say that that's something, if you fail to do it, it's something you can be held responsible for failing to do. And what Libet studies don't measure is this, let's say, conscious will to stop. What they seem to be measuring is awareness of conscious will, right? So a mental state whose object is the conscious will to stop. So not that. And then even more recently, there's been work that suggests that the RP isn't anything real at all. It's just an artifact of the way the scientists have arranged the experiments. So if you take a bunch of trials and you average them together, you get something that looks like an RP. But modeling studies have shown that a pretty standard diffusion to bound decision-making model, which I will explain more of later in the talk, gives you both the distribution of willing times that people actually exhibit when they randomly decide to will, and reproduces the RP even though there's no signal in the brain that actually is an RP. It's just the statistical sum of a diffusion to bound decision-making model. That's a lot, but I'm not going to have time to unpack it now, and we can talk about it more in questions. So I'm going to just say of the Libet studies, I don't think that there's anything in those studies that suggests that we don't have free will. I don't think those studies measure free will at all. There are other studies that have claimed to show that you can measure people's intentions prior to them knowing that they've intended to do something. So I'm going to show you a short clip from 60 Minutes. Let's see.
John Dylan Haynes is hard at work here, using the scanner not just to identify objects people are thinking about, but to read their intentions.
There you go. So we're going to start now with the actual experiment.
Subjects were asked to make a simple decision, whether to add or subtract two numbers they would be shown later on. Haynes found he could read directly from the activity in this small part of the brain that controls intentions what they had decided to do.
This is a kind of blown up version of the brain activity happening here. And you can see that if a person is planning to add or to subtract, the pattern of brain activity is different in these two cases.
So that doesn't go to show that you can tell that people don't have free will, but then he went on to show that he can detect those patterns of activity prior to people's report of being aware of making the decision. And so here's one of the figures from his paper, and essentially what he's arguing is that at that red line, so the dotted line in these graphs is when they actually, this is actually for a motor activity, but when they actually move. And then the red line shows you when they are reliably above chance at predicting what the movement is going to be. And basically he argues that for about 4 or 5 seconds before somebody is going to move, he can predict what their movement's going to be. And if that were actually the case, that would be fairly dramatic, because they don't report having decided that far ahead of time. But then if you look at the other axis, 50% is 50%, and then the predictive power is, actually this is the part here, he's up around 57% predictive power. Now, if we were really determined and he could measure this, he should be able to measure it all the time. 57% still gives us a lot of wiggle room if you thought that determinism was going to rule out the ability to have free will, but that indeterminism would preserve it, because basically you're just getting a little bit of boost over pure chance. And then think about what it is to do this task. So in this task, he's asking people to move the right or left finger. And typically when you do this task, what you end up doing, if you do the task, is you do a couple finger taps, and then you think, well, I just alternated one, then another. But that's not random. I have to do something different. So maybe I'll do the same one again. Ooh, I did 3 of this in a row, so I should change it up. So you're essentially rehearsing what you've already done in order to make sure that you have some kind of random sequence. And if there's any kind of statistical regularity between what you've done and what you will do, that's going to be able to be predictive in, to give you some predictive power over your next move. And so this data is completely consistent with you having some mental record of what you have done, and maybe having some statistical connection between your past and your future actions. So again, I don't think anything in this data suggests that we lack free will. So although I think it is true that some studies suggest that there's decodable information when an intention is consciously held in mind, that alone is nothing to challenge the idea of free will. And I think that there are also studies that suggest that there are causal factors that you can detect prior to this, to decision making. But it isn't true, or there's no evidence that those things are intentions or that those things actually have causal power. In fact, we expect that our future actions are governed by our past experiences, and so any record of our past experiences that might inform our future actions could be the signal that you pick up when you get something over chance. So again, no studies show that any brain activity determines action prior to and independently of awareness. Okay, so now I'm going to turn to decision making. And I'm going to talk about mechanisms of perceptual decision making that have been studied by Mike Shadlin in monkeys. I will first give you a little explanation of the task. So what Mike tries to do is to ask monkeys to look at a stimulus. So they actually fixate a point on the screen, and then visual stimuli are put on the screen, and the monkey has to make a decision about those stimuli. And in these experiments, what they're given is a random dot motion stimulus, and they have to decide, are the majority of the dots moving to the right or to the left? And once the monkey has made his decision, he signals the decision by moving his eyes from that fixation point to a target that's either on the right or the left. And while they do that, they record from the monkey's brain, and I'll show you recordings from 2 different areas, and get evidence from that about the mechanisms underlying decision making in this task. So this is what the monkey actually sees, and it would be better if the lights were out for this, but how many of you monkeys think that the dots are moving to the right? And how many of you think the dots are moving to the left? Okay, so most of you have no idea, and a small proportion, about equal, have suggested it's to the right. Now it's on? Can you hear? Yes. Okay. So in MT, essentially you get a signal that corresponds to motion in the direction that the neuron prefers. So if it's preferring, let's say, here, rightward motion, you would get high response in these cells for a strongly rightward stimulus and lower for less strong. And that makes sense because we know that these cells respond to visual motion in a particular direction. If you record from an area called LIP, instead of getting this kind of flat profile, what you get is a ramp. And the slope of the ramp is very high when you get very strong motion to the right. And all of you who saw the strong stimulus could decide very quickly that the dots were going to the right. But if you had a less strong stimulus, it would take you'd have to look longer. You'd have to integrate over more time to get enough signal to make your choice. And that's in fact what happens. And so if you average all of these traces to the time at which the monkey responds by moving his eyes, you can see that the strongest motion has the shortest latency between the baseline and reaching that threshold point, whereas the less strong signals take longer and longer. And so this is exactly what you would expect if this decision-making system were essentially a diffusion to bound, that you basically needed to get a certain, or you integrated over time until you reached a certain strength of activity indicating motion in one or the other direction that would then trigger the response. Now, I think that this is pretty much how decision-making works, and you might say to me, well, no, this is just some perceptual input from the world. The decisions we make have all kinds of other things incorporated into them. We care about value, we care about probability, etc. Well, it turns out that these LIP neurons also care about those things. So if you promise monkeys rewards that they prefer, the neurons fire more. If you give them rewards that they're not crazy about, the neurons fire less. So they're modulated by value. If the monkey thinks it's very probable that the motion is going in a certain direction, those neurons are going to fire more. And so all of the aspects of decision-making that we think of when we think of human decision-making are actually present in the firing of these cells as well. And so you can model decision-making as this kind of diffusion to bound, where you have lots of different kinds of evidence. You have perceptual evidence, evidence about value, evidence about expectation, evidence about costs, etc. And the system essentially integrates information from populations of neurons until the activity in that system reaches a threshold, and you can consider those thresholds as being options in a test or propositions like, you know, I will go to University of Iowa versus I will go to University of Kansas. You know, so decisions can be modeled in this kind of framework, and it turns out that it's exactly this kind of framework that allows you to, so if you think that this is a model for decision making and you simulate this with a Libet type experiment in mind, you can recover the form of the RP, so the dark line is the essentially the distribution of latencies for W given the empirical data. When you actually ask people, move whenever you feel like it, they're going to have different lag times before they move. And if you just make a histogram of those, you'll get a certain shape. And if you see what the model does with this kind of structure, you get almost complete replication. And you can recover the shape of the RP by averaging all these trials to the moment of movement. So we can explain the presence of the RP, which turns out to not be a real thing, but just a statistical artifact of the experimental design from this decision-making model. Okay, so I think all of this points to something interesting, which is it looks like our decision-making processes are mechanisms of some sort. They're neural mechanisms, and we're starting to understand the basis of those mechanisms. But there's nothing in this data that suggests that they're deterministic mechanisms. So I think it's important to distinguish the notion that something is mechanistic from the notion that it's deterministic. So you can have indeterministic mechanisms as well. Mechanistic also doesn't imply indeterminism, right? So those are just different things. Now, I don't think that this leaves us sitting very comfortably. I don't think it says anything about free will, but I think it does say something about the nature of who we are that we're not necessarily comfortable with because we don't think of ourselves as mechanisms. And how can we have mechanisms that are free? Now, some people think that mechanism is really what was the problem all along, that philosophers are wrong to think that determinism was the problem, but that when people were considering determinism, they actually were implicitly imagining mechanism and not determinism. But what I would like to suggest is that what I think really worries us is the equation between mechanism and mindlessness. And it's just, I think, maybe the fact that most of the mechanisms we're familiar with aren't minded. But I don't think there's any reason to think that mechanism implies mindedness. And I think that's one of the really interesting areas for philosophy and neuroscience, is to show how mind can be recognized in or realized in mechanism. So here's a Dilbert cartoon that at least illustrates the puzzling features. So the dog says, "Do you think the chemistry of the brain controls what people do?" Of course. Then how can we blame people for their actions? Because people have free will to do as they choose. Are you saying that free will is not a part of the brain? Of course it is, but it's that part of the brain that's just out there being kind of free. So you're saying the free will part of the brain is exempt from the natural laws of physics? Obviously, otherwise we couldn't blame people for anything they do. Do you think the free will part of the brain is attached, or does it just float nearby? At this point, he says, "Shut up." And I don't know if you're familiar with Jonathan Haidt's moral dumbfounding, but I call this metaphysical dumbfounding, right? There's a point at which our ability to explain runs out. But I will try to at least sketch what I take to be a positive story, which I call the capacitarian point of view. And basically what I think it is to be free is to be an organism in possession of certain kinds of capacities. And they fall into different groups. So there's a set of cognitive capacities or a cognitive demand, like the capacity to appropriately represent the facts, or might be the moral facts if you're trying to make moral decisions, capacity for valuation of options and calculation of utility, the capacity perhaps to represent yourself, maybe even to represent yourself as a rational agent or an intentional agent. I'm not sure. There may be others. I'm happy to take suggestions. And then there's also a control demand. So we have to have a capacity for motivated action. We have to have the right kinds of links between our cognitive and motivational structures. And we have to have effective mechanisms of inhibition. So you can cash these out a little bit more in neuroscientific terms, right? So there are parts of the brain that seem to be involved in representing the way the world could be or is. Cortical areas, for instance, they're sensitive to evidence. We represent a hierarchy of goals and norms. So we have different kinds of systems, subcortical systems that are involved in signaling a reward. And we have ways of hooking up those subcortical systems with the cortical system so we can assign values to different kinds of options. So ventromedial frontal cortex, it's a favorite brain part of the University of Iowa. Damasio was here and did a lot of work on that. We have to be able to assign value to options in relation to goals. And so there are ways in which our neurons represent reasons. We don't understand those yet. And ways in which our cortical representations are modulated by reward contingencies. So these are part of what the brain version of the cognitive demand could be. And then there's also an analogous control demand. So the ability to reassess and evaluate goals. And so we know that some of that happens, at least in orbitofrontal cortex. Other kinds of structures that resolve conflict and inhibit automatic responses, dorsolateral prefrontal cortex and the anterior cingulate are favorite areas that seem to do that, and other areas that are capable of acting on the output of the cognitive system. This is sort of the neuroscientific, very broad way of cashing out this kind of capacitarian view. There's analogous thoughts in the philosophical literature. So, for instance, Fisher and Revisa talk about reason responsiveness, and if you try to understand what reason responsiveness actually boils down to, it includes the capacity to do all these kinds of things. And again, I think reason responsiveness is not something that's threatened by either mechanism or determinism. So I'm going to wrap up now. I think there are things that matter to free will and responsibility. I think things that matter are that we make our choices, that our choices involve the right kinds of psychological states, that we have certain kinds of capacities, including those to represent facts and to deliberate and to re-deliberate or re-evaluate if we have new evidence. In other words, that we are reasons responsive. And I think that neuroscience is starting to show us what those kinds of capacities look like when cashed out in a brain system. And I don't think that neuroscience is going to show anything that disproves free will, but it might tell us very interesting things about, let's say, cases on the edges, right, where we are not sure whether somebody should be held responsible for their actions, and we might be able to find out that actually they're deficient in some central, some system that's central to what we think of as the system underlying one of these capacities. And so in individual cases, it may be that neuroscience could be very enlightening. And if we're thinking about what free will in the age of neuroscience has told us this far, I think that, I've tried to argue anyway, that no result that neuroscience has yet given us disproves ordinary notions of free will. In particular, none of them show that we're determined and that we are, therefore not authors of our actions in some sense. And no result also shows that conscious will is not efficacious. And I think those are the two threads that if you hear neuroscientists or philosophers talking about neuroscience saying, oh, it's shown, it's demonstrated that we don't have free will, those are the things that they tend to be talking about. I think we are starting to understand some of the processes that underlie decision making and initiation of action. And I think that we have inductive evidence, we don't have any demonstrative evidence that we are just material, mechanistic, complex, and very interesting mechanistic systems of a sort, but I think it's still inductive evidence. I mean, we're starting to show what the mechanisms are that underlie some of the things that we have thought of as being somehow uniquely human, tied to our souls or minds in some immaterial kind of sense. And so I'm at least hopeful that more neuroscience will give us more insight into these questions. And then we can think about the future, about what neuroscience can and cannot do. And one thing that I haven't argued for very explicitly in this talk, but something that I believe is that neuroscience is not going to be able to solve the problem of free will in the absence of philosophical input, both philosophical analysis and some kinds of philosophical commitments. So I think that any question or any answer to the question of free will is going to be at the foundation philosophical. Neuroscience, I think, cannot resolve the determinism-indeterminism debate. If it's going to be resolved by science at all, it will be resolved by our best physical theory. But our best physical theory has both indeterministic, our current best physical theory has both deterministic and indeterministic interpretations. And I think that neuroscience can suggest that the problem of free will needs to be reformulated. It can inform and constrain our philosophical thinking, but only once we have certain philosophical commitments articulated. And so, thank you very much for your attention, and I'm happy to take questions.
Switch to that mic and I'll give this one to David.
Well, toward the beginning of your talk, you went rather quickly, perforce, I think, over this dichotomy between determinism and indeterminism, and the difficulty we might have in distinguishing deterministic systems from indeterministic systems. There's a lot there, and but there are two things that I'm particularly interested in. One is that even if you don't know whether a system is chaotic or indeterministic or deterministic in terms of its ultimate ontology, it might not matter. That is to say, for all practical purposes, if the system is sufficiently macroscopic, you may get something that amounts to predetermination. That is to say, if the brain is at a certain state at T1, and you can account for all the inputs and outputs and so on, then you're going to get something that doesn't just predict, but in effect determines the state at time T2. I mean, so far as complicated things like real actions are concerned, there isn't going to be any possibility of any practical sort to do anything otherwise than what is predicted. The more fundamental question, though, it seems to me, is one. I wasn't quite clear what your view is, but it does seem clear, doesn't it, that whether a system is deterministic or indeterministic, if that's all there is to be said about the matter, then we can kiss free will goodbye, because an indeterministic system, absent something further to be said about the story, is a system which is essentially a loose cannon.
Right. You've got randomness, or
so there must be an interesting further story to tell.
Yeah.
And would you agree that part of that interesting story should be that the kind of personhood that is required in order for us to be genuinely free is one in which something does determine our decisions. they're not random or indeterministic or simply a product of statistical fluctuations of some sort.
Yes.
But it better not be causal determinism, or else we're stuck with what looks like hard determinism.
Well, I'm with you until that point.
Sorry?
I'm with you until that point. So I think you're right. I think actually determinism is a red herring. I don't think the question of free will hinges on determinism. And so I do think that that the account of freedom is going to be orthogonal, and I've sort of sketched it out. And I think that you could imagine things that had those capacities that were both deterministic or indeterministic. But the thing that does, that we hope actually governs our decisions are the reasons that we have for making those decisions. And so I don't think randomness gives us the freedom that we want. So Robert Kane has a view of a libertarian view where he thinks that you could be a system that is determined almost all the time, but if you had some indeterministic events happen at the right times in the past, that is enough to ground freedom. And I think his view, so that speaks to what you were saying about being, like, for all intents and purposes, deterministic. Well, he thinks that actually those few random events are of critical importance, and I disagree. I think that the things that matter for freedom are just not those things, right? So there might be a certain level of simplicity of a system that would cut out the possibility of attributing freedom to that system, right? And any system that's going to satisfy the criteria that I talked about at the end is going to be a complex enough system that that's not going to be the case. Or, I mean, I don't know exactly, how to characterize where that cutoff is going to be, but to do the things that I talked about, we can't build anything like that thus far, for instance. But anyway, so I think that you were completely right, but when you at the end said, well, but if it's going to be deterministic, then we can kiss freedom goodbye. I don't think so. I actually think that determinism is compatible with freedom as long as it's a deterministic system of a particular kind. Are you taking my questions? Picking people?
Yeah. Emily? Great.
Oh, was I was.
Oh, yeah.
I don't need this. I have a mic now.
You do have a mic.
Yes. I just took it without thinking.
Well, first I want to say thanks for your talk, because I really enjoyed it, and I have a million questions, but I'll limit myself to one. So I'm personally sympathetic to the sort of line you gave by Green Cohen earlier, that let's just ditch this talk of blameworthiness and so on and so forth. But it sounds like you're not. And you're trying to rescue that with this capacitarian sort of view. Yeah. But I'm thinking that the list of capacities that you gave that are required to be sort of blameworthy, I don't take it that you think that having those capacities or lacking any of those capacities would necessitate an agent to go out and do a bunch of bad things, right?
No.
Okay, so in that case, then there's the possibility of people who lack those capacities and do good things.
Sure.
I'm thinking in particular, one of the things that you listed as a capacity was inhibition control.
Yeah.
My stepfather's grandmother had a car accident when she was young that I've forgotten which part of her brain. I don't know parts of the brain very well. It affected one part of her brain. It made her very, very difficult for her to control her inhibitions. And so she would just say whatever she was thinking. It was quite a lot of fun. Sometimes not so much fun, depending on what she was thinking. And she would also just, being a good-natured person, run out into the street to help people, if she saw that someone was in need of help. And so she was lacking this kind of inhibitive control, but doing a lot of good things. And based on your account, so we say that she's not like praiseworthy. She's not a moral agent, because the account seems to imply that we don't hold people blameworthy if they lack that kind of capacity. So I'm wondering what you would say about that kind of case.
So I think that the question of whether there's symmetry between blameworthiness and praiseworthiness is in itself an interesting question, and I'm not sure I just want to buy into the equation of those two. So I'll just say that as a caveat, but I also doubt that your grandmother truly lacked all inhibitory control capacities. I mean, I don't think that she may have had more difficulty than other people. I don't think that makes you not a moral agent. I think there are lots of people in our criminal system who have diminished capacities in certain respects, and I still think that they are, at least many of them, are still responsible for their actions. So
those capacities have to be totally absent, those capacities.
Well, there has to be some, I think cashing it out, if you were, trying to translate this for, legal purposes, right? Cashing out what level of capacity one must have had, I think is going to vary a lot, right? I think, for instance, if you have slightly diminished capacities to not commit murder and you commit a murder, I think you're blameworthy. If there's absolutely, if you're completely psychotic and can respond to no reason whatsoever and you commit murder, maybe you're not, right? I mean, you're crazy. You're eligible for the insanity defense, right? And there's a big spectrum in between. And so I don't think that anyone, look, I think all of us have capacities to different degrees, but I think that I'm at least willing to bet that we all pass whatever the threshold is, right? And so that's, I would guess that your grandmother passed it as well.
I'll push your perception.
Okay.
So, you kept saying throughout the talk that none of the neuroscience disproves free will. What sense of free will did you have in mind there? So your particular sense of free will seems like something like compatibilist free will, right? When you were talking throughout the talk, what exactly did you have in mind?
Well, I am a compatibilist,
right. So,
but if you were an incompatibilist and of either variety, right? I don't think that we have evidence from neuroscience that tells us that our brains are deterministic or that tells us that indeterminism is true. I think neuroscience is just not able to speak to this issue. And so I think you could be happy in your philosophical views, regardless of what they are, because I mean, at least when it comes to thinking about what neuroscience has told us. Now, I further think on philosophical grounds that the question of determinism is just not the question to be asking with respect to free will. And that goes against, a long history of philosophical debate, and theological debate. Right? So I think, compatibilists basically, at least most compatibilists, just don't care whether or not determinism is true. They just think it's compatible with freedom. But, there's some compatibilists that think determinism has to be true, taking your insight to its extreme, that unless everything were, in some sense, causally determined, the randomness would undermine freedom. But,
For specifically, sorry, can I? Specifically, as regards to your capacitarian view, I know you say sort of neuroscience now can't isolate subsystems, you said earlier on, but imagine sort of future neuroscience. You think that it's in principle, if I got you correct, it's in principle impossible for a future neuroscience to be able to map out exactly what's happening in the brain when an individual makes a certain decision, or exactly what's happening in these different capacities of the brain.
Yeah, I really do think it's in principle impossible.
And I was unsure
why.
Yeah, I know you spoke a little bit about it, but
for one thing, at least all the techniques, or almost all the techniques we have now, are disruptive. So, like, in order to record from a neuron, you have to put an electrode in the brain and kill other neurons, and to have a complete knowledge of the state of every neuron simultaneously, I just think is not achievable. And I think if you don't have that complete knowledge, then your missed predictions it's not diagnostic, whether you failed to predict what's happening because there was an indeterministic event or because you missed information that would have predicted it. So.
Hi, thank you so much. I learned a lot right here.
Okay.
Yeah, I have one question and one thing I'm confused about. The first one is when you presented the Smilansky's paper, seems to me that he rejects free will but thinks it's necessary. He thinks free will is an illusion, but it's necessary. And his reason is that, everything is going to be chaotic. I mean, people are going to maybe do things that, crimes and all that. But I did not see any evidence for his claim in the paper that, and so maybe you can talk about that real quick. And the second thing, when you, on that slide, when you presented determinism, hard determinism versus libertarianism, and compatibilism is the one in the middle. This is maybe more general, but why is I understand that libertarianism is that it's completely free will, but why is it called libertarianism? It's not the political position.
No. It isn't. I'm not sure I can give you an answer to why it's called that.
Okay.
I didn't choose it. But it's been there for a while. So maybe somebody else here has a better historical grasp than I have.
Thank you.
But so it's just the name that applies to that version of incompatibilism, the belief that we are free, but we're free in virtue of indeterminism. With respect to Smilansky, I did not provide his argument, but it's something like, the world is causally determined, determinism is incompatible with free will, but if we don't have free will, we don't have moral responsibility. If we don't have moral responsibility, the world will go to hell. So let's not tell people that there's no such thing as moral responsibility. So that's a caricature of how it goes.
Two more quick questions.
And to just get the flavor, and I think this gentleman whose name I don't know pointed at the same thing. The problem is from a hard incompatibilist point of view, let's call it. If you think determinism rules out the possibility of freedom, that seems intuitive to people, but the negation of determinism is randomness. So if the reason that you do the actions you do is just due to a flip of the coin or God's dice or whatever, then you're not responsible for the decisions you make, right? So indeterminism is incompatible also with free will. That seems to leave free will in a pretty bad place. So that's why some of these philosophers will say, we don't have free will, but even regardless of the determinism question, and the compatibilists say, no, there's a way to give an account of free will that's just independent of that issue.
Hello, Professor. First of all, thank you so much for the talk. I mean, these used to be, I mean, we always think about these issues, but I always had like a more of a dismissive position with regard to these kind of things. I mean, I used to think, well, neuroscience, blah, doesn't really tell you much about free will. That's the end of the debate. And so it helped me to really think about these issues closely and sort of deeply engage with them. I just had a clarificatory question. So you started out with a fundamental question that does neuroscience really prove determinism, or does it really help us to resolve the determinism indeterminism debate? And if I get you correctly, your answer is, in principle, it cannot actually resolve that particular debate. And so you talked about, towards the earlier part of your presentation, you talked about two problems. One was the problem of fundamental neural indeterminacy, and the other one was the problem of exhaustive neural determination. And you sort of use these two problems to highlight the limitations of the neuroscientist, right? So the question is, would you then say that these two problems that we have with regard to neuroscience, it kind of shows that these are in principle indispensable systemic problems with the neuroscientific approach, and therefore they cannot in principle prove much about the debate? Or you think, as far as these two problems are concerned, they are just a problem given the state of affairs with the advancements we've made in neuroscientific research?
No, I think these are in principle problems that neuroscience will not address. But I think neuroscience is really crucial to understanding the basis of free will. So, I think understanding how our brains realize the kinds of capacities that we have is going to be incredibly enlightening and important. And so I don't want to say that neuroscience is irrelevant to the question of free will, but I think if you think it's going to solve it by addressing the determinism problem, I don't think you're going to have that ever.
Thanks.
Hi, just a quick clarificatory question about one of the studies. So when you have a case where we're examining like the monkeys and they're looking at the dots, is it the case, so just to clarify, are the monkeys primed before the experiment so that they will cooperate with the experiment, basically? Like, is that how we get them to kind of like look at the dot one way or the other, or is this just, we don't have to prime them for a case like that?
No, they have to learn the task, and they also know that they get rewarded when they do the task right, and they have a timeout when they do the task wrong, so they're motivated to do the task correctly.
Great. Well, thank you all very much for coming to this wonderful talk. Thanks. And thank you.